Hello, in this video we're going to be talking about the other trig functions. So at this point we know what the derivative of sine is and what the derivative of cosine is, but we haven't talked about the other four trig functions, and it would be good to know what's going on with them. And we're going to do a little bit of a proof to figure that out. So I've got h of x is tangent. I want to show that h prime of x, it turns out to actually be secant squared x. Well, where does that come from? Well, you can use the quotient rule on this thing. So we know tangent is sine over cosine. So we could, if I find it, there we go. So h of x is sine x over cosine x. And then we can apply the quotient rule of that. We do the derivative of sine, that's cosine. So that's the derivative of the top times the bottom, minus the derivative of the bottom, which is, oh wait, no, this is the top. And then here's the derivative of our bottom negative sign. I was worried I had a sign error there. I get it. And then on the bottom, we've got the bottom squared. So next we just try to simplify that down a little bit. This cosine times cosine is a cosine squared. Sine times sine is a sine squared, but since those are both negative, we've got a nice positive in the middle. Then what you may remember is cosine squared plus sine squared. That is one of our trig identities. And it turns out to be just 1. Cosine squared plus sine squared is 1. So our final thing ends up being h prime of x is 1 over cosine squared. And 1 over cosine squared is secant. So that is a proof. You have two options. You can either just try to remember, which is my recommendation, that tangent is secant squared, but that wasn't too crazy to do the quotient rule on that. So if you're ever really, really stuck and caught in a corner and you need to figure out what that derivative is, just do the quotient rule and then you're all set. We could follow a similar process with the other trig functions, applying the power rule and particularly the quotient rule, in order to figure out these other derivatives. But we're just going to say, hand wavy, that is how we find all of our other derivatives. Let's try doing that in this exponential function. You can see why inside of this exponential function, it would be kind of annoying to try to do quotient rule inside of that thing. So I am going to use this definition thing of what the derivative of cotangent of x is. So I'm going to start out by identifying my stuff. My a value, the thing that is the base of my exponential, is 3. The exponent in my exponential is cotangent of x. And so then our u prime, the derivative of whatever that u is this thing that they've given us over here. So that's negative cosecant squared x. So our y prime is going to start with the ln of a. So that equals the ln of whatever our a value is, which is 3, multiplied by just a of u. So that's just what we started with. So that is 3 cotangent of x. And then we need to multiply that all by, I'm running out of colors, u prime. And so u prime we found to be negative cosecant squared x. Now that's written a little goofy, so I could probably try to clean it up a little bit, but I don't necessarily need to. We are not in the simplification game. So I could probably maybe put that one first, and then the ln of 3, and then a 3 cotangent of x. I don't know if that's any neater, but that is just an alternative way to write it. But that is the derivative of that function. In this example, I am looking for the equation for the tangent line of the curve at P. And they're kind enough to give me a point already. It's pi over 2, 2. But I do need to figure out what my slope is. And the slope of the tangent line is always our derivative. So we need to find the derivative of y. So y prime is going to equal the derivative of 4. Well, that's just 0. The derivative of cotangent is right up top here. So that's negative cosecant squared. CSC squared x minus, and then we've got a 2 cosecant x. So we're going to keep that 2. And then the derivative of this cosecant x is going to be all of this jazz. So that is CSC x, but it is negative. So I'm going to change that to a positive, and as well as a cotangent of x. Okay, but we need to figure out what the value of our derivative is at that point x. So at this pi over 2 spot. So we need to find y prime of pi over 2. So we're going to put a pi over 2 into this thing. All right, so I've plugged in my values. So y prime of pi over 2, we need to figure out what the negative cosecant squared of pi over 2 is. Well, that's 1 over sine of pi over 2. Sine of pi over 2 I know to be 1. So 1 over 1 squared is just going to be a negative 1. 1 plus 2, we just talked about cosecant of pi over 2 is also going to be 1. And then the cotangent of pi over 2. So cotangent is cosine over sine. Cosine of pi over 2 is 0, and sine of pi over 2 is 1. So we have a 0 over 1. So this is 2 times 1, 0 over 1, blah, 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 blah. That's just a big, long pile of nothing. So y prime of pi over 2 is going to be just that negative 1. So we need to write an equation for p at that point for the we need to write an equation for the tangent line at p. So we use our good old friend point slope form. So y minus our y value, which is 2, equals negative 1, the value of our derivative, the slope of the tangent line at pi over 2. And then x minus our x value at that point, which is pi over 2. So there is our equation for the tangent line at P. In part B, we're looking for a horizontal tangent line to the curve at Q. That means we want the tangent line slope to be 0. The slope of the tangent line, the derivative, has to equal 0 at Q. So we can just replace this y with 0. And now we've got to solve that equation for x. Okay, well, I see some cosecants, so I'm going to factor those out. So we get 0 equals, let's do CSC x. And then I'm going to put that 2 cotangent first, minus that CSC. And I'm not much of a fan of solving for cosecant and cotangent, so instead I'm going to convert them all into sine and cosine. That just makes it a little bit easier for me to solve. So this is 0 equals 1 over cosecant is sine. It's cosine over sine. Minus another 1 over sine. So looking at this, it looks like I didn't take out quite enough. I should have taken out an additional sine, so I'm going to do that as well. Now that I've done that, I look at that 1 over sine squared. Could that ever equal 0? No, if it's like a reciprocal function, and reciprocal functions never equal 0. So this is not going to produce any solutions for me. I just can't get that to equal 0. That 2 cosine x minus 1, that could potentially get us some 0. So let's take a look at that. So 0 equals 2 cosine x minus 1. Do a little solvey. We get cosine x equals 1/2. And then we're like, oh, okay, cool. Now we're getting stuff. The cosine of what is going to get us 1/2? Well, let's see. Cosine counts down, so that's going to be pi over 3 in the first quadrant, and then it would be 5 pi over 3 in the fourth. If we just kind of think about our first time around stuff, there'd be an infinite number, but we don't really care about that. We just care about ones that are about right here. So it looks like it's about at 1. So that would make sense. This is like 3.14 divided by 3. That's about at 1. So it must be this pi over 3 location. So that is the x value for our tangent line. However, in order to draw that horizontal tangent line, I don't need the x value. I need my y value. Ah, dang it. I don't have that yet. If only I had an equation that equaled y. Oh, silly problem. You gave it to me. That equation equals y. So we got to plug in that pi over 3. All right, plugged in. So cotangent of pi over 3, that's cosine over sine. The cosine of pi over 3, we were just talking about before, was 1/2. And then the sine of pi over 3 is the square root of 2. No, that's blah, blah, blah. The sine of pi over 3 is going to be the square root of 3 over 2 minus 2 times the cosecant of pi over 3. Cosecant of, if that's 1 over sine of pi over 3 is thing. Sine of pi over 3 is, I literally just did it, as square root of 3 over 2. Ah! All right. Now, if we were in the simplification game, because why not, we could simplify this thing down, but we are not. But this is going to end up being our tangent line, because our tangent line is just a horizontal line. Horizontal line are just y equals something. So once we figure out what this y value is, that will be the equation of our tangent line. So this is 4 plus 1 over the square root of 3 minus, let's see, this 2 doesn't really do much there. I'm just going to put it right there, just to kind of get it into that fraction. So we get 4 over the square root of 3 if I multiply top and bottom by 2. So this equals 4 plus 1 over the square root of 3 minus 4 over the square root of 3 is negative 3 over the square root of 3. We could rationalize that thing, and we get 4 minus the square root of 3. That is about as simple as you can make it. Oh, it's not just that. It's the equation y equals 4 minus the square root of 3. That would be the equation of our tangent line, that horizontal tangent line at Q. So our horizontal tangent line at Q, 4 minus the square root of 3. I said that like 6 times, but you get what I mean. That is it for our video on other trig functions. So the main things you want is sine and cosine. You can find these other ones using the quotient rule. Tangent and cotangent tend to show up, but cosecant and secant are a little less common. So definitely no sine, definitely no cosine. Tangent and cotangent are definitely helpful to know because that's going to save you a chunk of time. But cosecant and secant tend to not show up very often and are much easier to replicate using the quotient rule, using sine and cosine. So, yeah, get to memorize. Boo, boo, boo. Great. Bye bye. Have a good day. Bye.